Please settle down. If you are just coming, settle down. I don't want any movements. I don't want any discussion. It is time for business. I would rather you pay attention to me and stop any kind of discussion so that you don't come and join me on stage. Okay? I know that you cannot even stand in front of your family and give a speech. Okay? So just stay calm for the few minutes we have to spend together. Just stay calm. Where did we stop in my last visit? Where did we stop in my last visit? Okay. We are talking about waves. Is that true? Okay. Now, in our definition for wave, we said that wave is a disturbance. Is that true now? And that disturbance is in what form of energy? Kinetic energy. And then when a wave moves through a medium, the atoms or molecules of the medium, are they permanently or temporarily displaced? Good. They are temporarily displaced. Good. That was what we discussed in the last class. And then we said that waves can be classified based on two criteria, right? And those criteria, the first one was what? Mode of propagation. Second one was what? Material medium required. Now, when you talk about mode of propagation, some of the waves are longitudinal, right? And some of them are what? Some of them are transverse. Okay? Those that are longitudinal, how do they travel? They travel parallel to their source, right? And then, can you give me an example? Sound. Okay? And those that are perpendicular, they are called transverse waves, right? An example is water waves and revoxy. Abi? That's that. Then, on the second category, we said we have mechanical and electromagnetic, right? Is it electromagnetic or electromagnetic? The bars, right? Very important. Okay, so we said that mechanical waves are waves that what? That require material what? Medium for their propagation. Abi? Can you give me an example? Water wave. Is water wave there? Sound wave, is it there? And so on and so forth. Then when we talk about electromagnetic waves, what are they? They do not require material medium. An example is revoxy. Abi? Class, among the waves we've talked about, which one is used for scans in the hospital? Soft or hard? Soft. Okay. Which one causes skin burn on exposure? Huh? Is it ultraviolet rays? Which one is used for WhatsApp? Is it radio waves? Yes. Okay, that's nice. I can see you and you can see me because of what? Is it visible light? Yes. Okay, that's nice. But don't worry, we'll test it. It's sometimes sometimes it's okay, so the last time we did not explain gamma rays, Abi? Yes. So we'll just explain that one and move on. We have a lot of things to do. Now, so let's talk about revoxy. And the last guy we're talking about is gamma. Where's Yoku now? Gamma rays. Now, if you look at all these radiations we've talked about, or the ones we've discussed so far, the one that is the most dangerous is these gamma rays. Which one did I say is the most dangerous? In fact, the main reason, when you talk about revoxy, when you are mentioning all of them, you need to add more bars to this one. Gamma rays. You add some bars, okay? Gamma rays. You can call this one radio waves, light waves, and so on. But when you come to this guy, gamma rays. Gamma rays. Okay, so these guys are the most dangerous, and the reason why they are classified as the most dangerous is because they cause what we call mutation. Abi? Do you know what mutation is? Mutation is simply when there is a change in what? In genetic constituent. Abi? Imagine you used to be a boy before. You woke up one morning. And you now observe that you are now developing female features. Or as a female, you wake up one morning and decided, or not even decided, you now observed that you are now developing male features. For example, your voice that used to sound like Celine Dion before started sounding like my own. Or so many other things, okay? You know that something is happening to you. Something is happening to you. So, and one of the causal agents for mutation is gamma rays. Please, I don't want that noise. I don't want the noise. If your neighbor is disturbing, I give you the permission to slap that neighbor. Mawalo meanya. Okay? I give you the privilege. But check the size of your neighbor first. Okay? If your neighbor is bigger than you, please don't. I did not give you that opportunity. Okay? So gamma rays are the most dangerous because they cause mutation. Okay? And where can we find gamma rays? In fact, gamma rays are produced during a process known as radioactivity. Have you done that before? Yes. Okay? And you know when you say radioactivity, it is the spontaneous disintegration of an unstable nuclei, right? That is a nucleus that is not stable. And then for it to attain stability, it is emitting radiations, alpha, beta, and what? Gamma. Good. So that is where gamma rays is coming from. And if you know about gamma rays, you know that they have several properties. For example, they have the highest penetration power. Huh? Yes. Good. They have no charge. Abi? Yes. You see that because they don't have any charge, they are not deflected in both electric field and magnetic field. Did you remember those properties? Good. That is very important. So that is the aspect of radioactivity where gamma rays are coming from. So what are the uses of these gamma rays? There are several uses, and we're going to discuss only a few of them. Okay? So, for example, they are used in hospitals for cancer therapy also. They are also used in cancer therapy. Remember last time we discussed that X-rays are used for cancer therapy, right? Which X-ray class? Hard X-rays, right? Good. They are used for cancer therapy. Gamma rays are also used for cancer therapy. Okay? They are also used for cancer therapy because of their high penetration power and so on. Okay? And you should also know that gamma rays are the major constituents of nuclear bombs. You've heard of nuclear bombs, right? Good. So gamma rays or radiations are the major constituents or the major things that come out during a nuclear blast. And of course, when these things are released to the atmosphere and it comes in contact with organisms for a very long time, what happens? Mutation can occur. Mutation can occur. Mutation can occur. Okay, so whenever there is a nuclear bomb blast, you shouldn't be worried about burning up yourself. That one is the least of your problem. The problem you should be worried about is what now? Mutation. Okay, for example, during you heard about what happened in Hiroshima, right? In 1945, when the United States of America, my country, decided to bomb Japan, Hiroshima. That was how the Second World War ended. Okay? Now, when they dropped that bomb at Hiroshima, everybody went to their respective homes. Because that was basically the end of the war. Now, calculate 1945 to 2024 is about how many years? 70-something years. Okay? They are still feeling the effects of what happened till today. Because gamma rays were released in excess. You go to the soil over there, the soil is devastated. They are even begging weed to grow. You know, when you did agricultural science, what is weed? Unwanted plant. Growing where is not wanted. Now they are begging weed to grow on the soil. Weed said, no, I don't want to grow. Is it by force? Okay, because of what has happened. Now imagine what would have happened to humans those days. Okay, those people, they were not the, in fact, the list of their problem were maybe because they were burnt by the heat from it. Some of them were vaporized. But anybody that survived that explosion, your children will be suffering it now. Because any kind of mutation that happened that time is transmitted. Shebi? Genetics. Is that not true? That is it. For example, you are an Etiaku. I'm not saying you are an Etiaku. I'm just assuming you are an Etiaku. And then you now marry an Etiaku also. Okay? You know they say love is blind. Love is blind. Huh? Love is blind. So basically a family of Etiaku. Now imagine giving birth and then magically you want your child to be intelligent when there is no trace of intelligence in the gene. I'm not saying that it cannot happen. It can happen, of course, right? It can happen. God can decide in your generation what can change here. Not to go too much. Okay? And something would happen. And if that thing happens, something that has not been happening in a gene, if that thing suddenly happens, what do you call it? It has happened. Okay? So it can happen. Now let's continue. So now that we have talked about these radiations, please, any questions before we continue? If no questions, let's move on. Right. Terms used in waves. 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 Are we there? Number one. Number one. Cycle. Number one, cycle. Cycle. Have you written cycle? Oh, yeah, right. It is a complete up and down movement of a wave. It is a complete up and down movement of a wave. It is a complete up and down movement of a wave. It is a complete up and down movement of a wave. It is a complete up and down movement of a wave. Are we there? Full stop. Represented. It is represented by N. It is represented by any small letter N. It is represented by N. Full stop. Full stop. Class, what did we say cycle is? 1, 2, ready, go. That choir was not organized. 1, 2, ready, go. Good. Do you need to read that one to me? I am just giving you that one. So class, listen up, because I am not going to say it again. Now, when we talk about cycle of a wave, let me say we have something like this. We said that cycle is a complete up and down movement, meaning that whenever you see a waveform that looks like this, by the way, this is a transverse wave. This is a what? This is a transverse wave. When we talk about sound wave, I will tell you how we talk about sound. Hello, hey, that boy. Now let's continue. So by the way, this is a transverse wave. Remember transverse wave, they go perpendicular. Now, up and down. So when you look at a waveform like this, and they say you should count the number of cycles, just remember that one cycle is 1 up and 1 down. What did I say? One cycle is gonna 1 up and 1 down. So if I have this, this is 1 up, this is 1 down. This is one cycle. 1, 2, and 3. Are you with me, class? So if I have something like this, what is the value of N here? Look at it and tell me, what is the value of N? What is the value of N here? Is it 7? Make we count them. Make we count them. 1. Is this 1? 2. Uh-huh. 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 And what? Uh-huh. Forget that at the end it was not beautiful, but it's 7. This is 7 cycle. Cycle, sorry. Auntie, my spirit is telling me you are not following. Eh? No, it's not you. Look at who I'm talking to, the auntie. Yes. My spirit is telling me you are not following. Is my spirit lying? My spirit is not lying. Yes, the spirit cannot lie. Where are you not following? Just talk to me. You don't understand what I'm drawing. It's like warm, Abi. Okay, the counting. Okay, don't worry, you will understand it in Jesus' name. Good. So I said 1 cycle, 1. For you to count 1, it is 1 up and 1 down. So 1 up is not enough for 1 cycle. 1 up is just half. So 1 up, 1 down is 1. 1 up, 1 down, another 1. Do you get it now? So if we count, this will give us 7. Do you get it now? Good. Now, oh yeah, look at this one. Look at this one. Everybody, look at this one and tell me what it is. Imagine you have a cat in your house and the cat now does meow. How many cycles can you see? You cannot see anything, right? Okay, let me slow the meowing down. Let me slow it down. Meow. If you have eye, how many are you seeing? If you have eye, how many are you seeing? Is it 8? Okay, so this is 1, Abi, 2, 3, 4, 5, 6, 7, and 8. Where's Yoku now? Good. Let me give more examples before we continue. Okay? Because I want a situation where you are all following. Because you will see this in your exam. Now, I have this. I now draw this. What is the value of any in the diagram? What is the value of any here? Value of any is what? Let's count. This is 1, Abi, 2, 3. Now, this is just half. So that is why it is 3.5. Or you say 3.5. Huh? Huh? Good. That is how you count any. Is that okay now? Let's continue. Number 2. Number 2. Number 2. Number 2. Period. 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 Are you there? Oh, you're right. It is the time taken. 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 It is the time taken to complete 1 cycle. It is the time taken to complete 1 cycle. It is the time taken to complete 1 cycle. It is the time taken to complete 1 cycle. Have you done that? Yes. It is the time taken to complete 1 cycle. Full stop. It is represented as T. Capital letter T, please. It is represented as T. Capital letter T. It is represented as T. Please, I need more fresher markers. The one that is writing very well. Do we have any refill here? Is it refilled? Okay. Okay, refill this one. Okay. Now, class, what did we say period is? 1, 2, ready, go ahead. Again. Good. We said it is the time taken to complete 1 cycle. Oh yeah, pay attention again. So I have a waveform. I have a waveform. Now, so I move. How many cycles can you see here? How many cycles here? 1, 2, 3, 4. Is it 4 cycles now? This is 4 complete cycles. Now, if a wave was going from here now, A, this is point A, and here is point B. Class, from A to B, is it 1 cycle? Now, the time it will take to go through that 1 cycle is what we call period. Is what we call what now? And we represent that by capital letter T. So if we have a capital letter T, period. So the time a wave we use and go through 1 cycle is what we call period. Okay? I think in 2017 or 2018, I was teaching one boy, then he was in SS1. I was teaching him waves. And then the first day, I taught him about period and cycles and all that. Next day, I came back for class, and then I asked him, define period. Do you know what this boy did? This boy stood up and said, sir, period is the time taken to. I was like, what is the meaning of that one? He said, uncle, look at it very well now. Time taken to. I now reasoned it and said, it's true. Is it true? Is it true? Do you know what this is? How many cycles is this? 1 cycle. So the time taken to do this is period. So as you are going home today, you did not learn anything. Learn that one. You enter the bus. Period. Okay? Time taken to. You go home, they say, Chinaza, come and buy me something. Mommy, period. Like that. Okay? And you learn it very well. Class, what is period? No. You are not in the same spirit as me. Class, what is period? 1, 2, ready, go. No. I want to see your gesture. I want to see your gesture. I want to see your gesture. Oh, you don't want to do the gesture? But you like watching me do the gesture? Look at these human beings. Okay, God will judge you for me. Okay, so that is period. Now, right, mathematically, mathematically, big T is equal to big T. What does big T represent, class? Period. Big T is equal to small t over any. Big T is equal to small t over any on the board. Do you know what any is? Yes. What is any? Number of gain now. Good. Oh, yeah, write this one down. Small t is total time. Small t is total time. Small t is total time. Big T, remember, is period, Abi? Big T is period. But here, small t is total time. Small t is total time. Small t is total time. Have you written it down? Now, let's solve some examples very quickly, and we move on. Solve some examples quickly and move on. Okay? I want to be showing you what all these things are, so that when we go to the past question, by yourself, you will be getting me the answer. Okay, now. Now, look at the diagram. Look at the diagram. And they told us that small t is equal to 8 seconds. Meaning that the time it takes for the wave to go from here to here is how many seconds? 8 seconds. They are now asking us to find the period. Did we write the formula down here? Yes. We said that period is equal to total time over any. Abi? Are you looking at this? Period becomes equal to, what is small t? 8 over, what is any here? Is it 5? Any is 5. So 1, 2, 3, 4, 5. And when I divide that, what do I get? 1.6. 1.6 guinea seconds. So period is 1.6 seconds. Did you get that? I'm hearing no somewhere in the background. Please speak up or forever remain silent. Who says they did not understand? Sir, the fans, are they working? Eh? Light is not working. Ah. Are we ready? Oh yeah, number two. Number two. Let's look at number two. This is X and this is Y. This is X and this is Y. They said if the total time taken by the wave to move from X to Y, comma, find the period of the wave. Find the period of the wave. Find the period of the wave. Is it possible, class? Is it possible? Oh, to Y is 6 seconds. Find the period of the wave. Is it possible now? Good. It is very possible. It is very possible. So I tell them that period is small t over n. What did they give us as small t here? 6. So 6 over n here is what? 1, 2, 3, 4, 5, 6, 7 and half. That is 7.5. So 6 over 7.5 will give me what? 0.8 what? Seconds. And that is our answer. Are we following, please? Good. Good. That is a question. They said, what is the period? What is the period? What is the period? That is the question. What is the period? This is a typical JAM question. Okay? So they said, what is the period? So class, remember we said the formula is what? Small t over n. Are we now? Now, the confusion you're going to have is, am I going to add all this time? And the answer is no. You are not going to add all of them. Class, what is the final time there? 0.05. So your total time is 0.05 because time is not how do I put it? You don't have to come back in time. So this guy is the last time. So from here to here, it takes 0.05 seconds. That is what you have there. So 0.05 over number of cycle is what, class? 2.5. Oh yeah, help me and divide. Help me and divide. 0.02 Abi seconds, and that is our answer. But if you are smart enough, you know that you don't even need to do all this calculation. From the definition, you get your answer. And what did we say the period is, class? Time taken to complete getting one cycle. One cycle. From here to here, is it one cycle? Answer is 0.02. So you don't have to stress. But if you want to stress yourself, you can do this, no problem. You will still get the same answer. Okay? It's just a matter of which one can you remember. You know, one thing is doing it in class. Another thing is doing it in exam hall. Now. I don't know, have you ever been under exam tension before? And then you try to remember how to spell is. you see that common is becomes like the longest word in the dictionary. Okay? You just forget about it. It is exam tension. And I have also experienced it once. Okay? I was here at MDA teaching. I think that should be in 2018 or 2019. I was teaching, and then I think that was around, I can't really remember the time, but I remember it was our second semester exams. So before I came back from school that year, we finished writing exams apart from one particular paper. So, and the reason why we did not write it when others were writing the exam was because the lecturer was very ill. So they said we should go, that whenever he recovers, he will come and set his exam. So within us now, we were thinking that the man will take a very long time to recover. So after writing all the papers, I came back to Enugu, and then I forgot that I was even supposed to write one extra paper. I was not studying, nothing. But I knew that even though I had not studied, I would go and pass. Abi? Because I'm on how very well. So what happened now? I was in MDA that day teaching. Around that kind 12, my course rep called me. He has even called me before then, but I did not pick up because I was in class. But around 12, when my class was about to end, he called me again. I now picked up. He was like, Prime, where you dey? I was like, I dey Enugu, waiting the shop now. He said, that exam where they postpone. They don't fix some, and not today. I was like, how? It was now like the man called him this morning, and said that everybody should gather in school, that they will write it today or carry over. I was like, what the hell? And he said he has been calling me since, but I did not pick up. I was like, which kind of class be this now? What kind of nonsense is this? Now, what happened? Imagine the kind of pressure that entered me. Exam was by 3. I was in Enugu by 12. What did I do? I just rushed straight to New Market to enter Eastern Mass. Normally, when you go to Eastern Mass, boss needs so. Like, if you have never, no, go up the first person. Within 5 minutes, 10 minutes max, the bus has full. 30 minutes, no limit, the boss. Like, I don't know, right? That particular day where I needed to be in Oka Sharp, boss you. I had to wait. And after some time, people now feel the bus. I think around something like after one. I was like, no problem, I will still make it. I chebezie no driver. Obolo one old man. I came and them pa we just I get. At that, I wanted a young, vibrant man that wants to die. Okay? That wants to die. Not like die, you understand? You understand what I mean now, right? So, not like die, but someone that will go very fast. Like, but they give us that old man. And then, the man was just going so slow. I felt like coming down and using my leg to trek. Because my leg would be faster. I was like, what is this? And then what happened? After all the whole thing, I got to Unity Gate by after 3. Exam has already started. By after 3. And then I had to chatter keke. I never entered drop for my life or school. I had to enter drop straight to the front of the exam venue. When I got there, they refused to let me in. I was like, sir, please. I was begging the lecturer. The lecturer says the rule says that once you are 30 minutes late, you cannot enter the exam. It is a 2 hours paper. I was like, sir, I can get a D. Let me just enter here. The man said, no, that I'm already 45 minutes late. I cannot write it. That I should come back next year and write. I was like, sir, please, I'm coming from Beria. Please. I had to look for one of my uncles that is wicked. And just say, I'm coming from his Beria. I was begging. I said, sir, please. I did not even know this exam was today. I'm begging. I was begging. That I see me now from the Beria, and I'm the main person there. I was begging. So my class rep saw me begging, and then he just came out and was also helping me to beg the man, sir, please, you know, today was somehow for everybody, please, sir. I now entered. The man now agrees and now said, when everybody will submit you also, I said, no problem, sir. The man gave me paper. With all the tension, I forgot my reg number. Like, I was in 300 level then, no. That was in 2018 or 2019. I was in 300 level then. And I've been using my reg number almost every day for the past 3 years. But that particular day, I forgot my reg number. I had to ask my teammate, how far, waiting be our departmental code again. Like, it was not only that one self. Like, I could not spell simple things. Talk more of, in fact, I know I'd not read for that course. So I was like, guy, how far, wait till you don't write. Wait till you don't. And one thing I love about my department is that no matter how you are in exam hall, you will write. You must write something. So what I did was, I just looked around. And you know, once you are looking around during an exam, they know you are looking for something. Okay? I just looked at my class rep and then looked at some few friends. They now, all of them now chatter question. This one will give me number 1A. This one will give me number... Just like that. We're supposed to write 5 questions. I think I wrote about 3. Just, I think 3. Complete 3. And then result came out. I got a C. I was like, thank God. Thank God. Because I have never felt that kind of pressure before. So it is not just about doing it in class. Don't wake up me by see. Very simple. Yes. That is what you say. Very simple. When you now enter exam hall, something will now happen and you will not remember that thing again. What is wrong with is it this thing I failed? It's not your portion in Jesus' name. Amen. Yes, because some of you village people, they are really with you. Let's move on. Number 3 terms used in waves. We have done 2 examples on this. Abi 3 example, Abi? Oh yeah, number 3 terms used in wave. Number 3. Are you there? Frequency. Idego frequency. Oh yeah, right. Right. It is the number of cycles completed in 1 second. It is the number of cycle completed in 1 second. Class, let me ask you, Dipiko, is it 1 second or 1 second? Is it 1 second or 1 second? 1 second, right? Okay, then 2 will be what? Plural will be seconds. 3, Abi? It's equal. Let me tell you now, whenever you are doing physics, forget about your English. What did I say? Whenever you are doing physics, forget about what? English. In physics, it is the unit of time is seconds. Whether it is 1 or 2 or 10. 1 seconds. 2 seconds. Don't tell me 1 second, 2 seconds. Okay? Because if you go and say that 1 is 1 second, 2 is 2 seconds. What of 0.5? No, now this one should now be 0.5 sec. Because it's not up to seconds. Is 1 not more plural than 0.5? You don't get? 1 is a whole now. Something that is complete. 0.5 is half. So if you call this one 1 second, so this one should be 0.5 sec. So, but the unit of time is what now? Seconds. Now, let's continue. Have we said anything on that frequency? What did we say there? Full stop. It is represented by F. It is represented by F, small letter F. It is represented by F, small letter F. Have you done that? Full stop. Full stop. Full stop. Mathematically, comma, F is equal to 1 over big T. Mathematically, comma, F is equal to 1 over big T. F is equal to 1 over big T. Do you still remember what big T represents? Big T is what again? Period. Period. Good. So frequency is 1 over big T. Meaning we can say that frequency is the reciprocal of what? Period. You know what reciprocal means, Abi? That is inverse. So take note of that. So F is equal to 1 over big T. Now let's look at an example. If you look at this, let's say that total time here is equal to 10 seconds. And they said, find the frequency. Find the frequency. Is it possible, class? They said we should find the frequency. Now, but of course, if you look at this, if small t was given, that means we need to find big T first, Abi? We can say that big T, what is the formula for big T again? Small t over n. Akwezioku now. And what is small t here, class? 10. Over n is what? 1, 2, 3, 4. So 4. 10 divided by 4 is how many? 2.5 seconds. Akuya? But is the question asking us to find period or frequency? So we can now go back to this formula to say that frequency is 1 over big T. So 1 over, what is big T again? 2.5. So 1 divided by 2.5 is 0.4, and the unit is hertz. Okay? H-E-R-T-Z. Okay? That is a unit of frequency. But pay attention again. Remember, you are in JAM class. Remember, you are in JAM class. And when you go to an exam, you don't have a lot of time to do a lot of things. Nobody is asking you, how did you get the answer? Did they say show or work in anywhere? Nobody is asking you all that. If you can look up to the sky from where your head cometh from and the letter of the answer will fall, no problem. Nobody will ask you that. So you have to find ways to save time. Oburije hall is here. Recall. May God have mercy on your soul. Therefore, nobody's asking you that. Okay? So, how can we solve this question? Very easily. Class, I already told you that frequency is the reciprocal of period. But do you remember that this is period? So that means that frequency is N over T, the reciprocal of this guy. That is the inverse. Are you with me now? So N is 4, this is 10, which is 0.4. So you will still get the same answer, but at a shorter time. But this one now, we had to find period first. After finding period, we now use it to find frequency. So, but once you remember that frequency is 1 over period, or vice versa, you can just invert the formula for period and plug it in and get your answer. Huh? Don't worry. I know some of you don't like shortcuts. Anyone where you like, pick. Okay? But remember, time is of the essence. In JAM, you have 180 questions, right? Is it not 180 questions? 40 from biology, 40 from chemistry, 40 from physics. And then English is how many? 60. It's not 180. 180 questions to solve in how many hours? 2 hours. In 2 hours. And 2 hours is how many minutes? 120 minutes. Okay? So that means if you divide 180 by 120, you should get around 1.5. Okay? Is it 1.5? Is it 1.5? 1.5, right? Are you sure it's 1.5? 1.5. Okay, yeah. 1.5. So 1.5. Okay, that is no, that is not how we should do it. We want how many seconds or how many minutes for one question. So 120 divided by 180. That should give us 0. What? 0.67, right? Good. So that is about 0.7 seconds or minutes, sorry, per question. So 0.7 times 60 for me. Do 0.7. That is 42, right? Or 40. Okay? It is supposed to be 42. So that means 42 seconds per question. Or let's approximate it to 40. So 40 seconds per question. So you have to be very fast. Okay? Of course, some questions will take lesser time, okay? And then you can now use that time to add to other ones. Oh yeah, let's continue. Let's continue. Number 4 now. Number 4 term. We are still going to solve more questions on all these things. Okay? We're still going to solve more questions. Number getting now on terms. Is it number 4? Oh yeah, number 4. Wavelength. Sharp, sharp. Wavelength. 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 Oh yeah, let's write. It is the distance covered by a wave. It is the distance covered by a wave in one cycle. It is the distance covered by a wave in one cycle. It is the distance covered by a wave in one cycle. It is the distance covered by a wave in one cycle. Or it is defined as the distance between successive crests, or it is defined as the distance between successive crests, or it is defined as the distance between successive crests or troughs. Crests on the board, or troughs. Or troughs. Distance between successive crests or troughs. Full stop. It is represented by, look at the symbol there. This is the symbol. Inverted Y, like that. Y that is inverted. Okay? And that symbol is called lambda. Lambda. That is the symbol for lambda. Lambda. Have you done that? Okay. Before we continue, write down mathematically, comma. Lambda is equal to d total over n. D total over n. That is total distance. Okay. You can say where d total is total distance. Total distance. You still know what n is, Abi? N is what? Number of cycles. Good. Number of cycles. Okay. Oh yeah, let's explain what we've done so far. Now, we are talking about wavelength. We are talking about wavelength. So, what was my first definition for wavelength, class? The distance moved by the wave in Guinea in one cycle. So, if I have something like this, is this one cycle, class? Good. So, if here is A and here is B, the distance moved by the wave in that one cycle is what we call wavelength. So, from A to B, the distance moved is what we call wavelength, and it is one wavelength. Remember the time it will take from A to B. Time is different from distance. Are they the same thing? The time it will take to move from A to B, what do you call that again? Period. But the distance it will move from A to B, what do you call that again? Wavelength. So wavelength, and this is the symbol for wavelength. If you don't want to use that definition, you can use that wavelength is the distance between successive crests or troughs. What do I mean by that? When you look at a waveform like this, class, all the upward movements are called crests. Are called what now? Crests. Remember we said that A cycle of a wave is one up and one down movement. So for you to count one, you have one up and one down. Now, those up movements, they are called crests. Then the down movements are called what now? Troughs. So this crest and this crest are successive. Successive means they come one after the other. So ifochanka, ifonka. This is 1, this is 2. So 1 and 2 are successive. If I have 3 here, class, 1 and 3, are they successive? No, because there is another one in between, Abi. So the distance from 1 to 2 is still wavelength. The distance from 2 to 3 is still what? Wavelength. Then here and here, both of them are troughs. The distance between them is still what now? Wavelength. Huh? Good. And I now gave you a formula. This formula, of course, you might not see it in any of your textbooks, but you see questions like this in JAM. We're going to see that, don't worry. So we said that wavelength is equal to total distance divided by number of circles. We are going to see a question where JAM will give us something like this. Let me use this one as sample. We'll see something like this. And JAM will tell us that maybe here is X and here is Y. And JAM will tell us that from X to Y is maybe 8 meters. And now asks us to find the wavelength of that wave. So the problem now is, if you don't know that formula, you will not even know what to do. So I now told you that wavelength is total distance divided by number of cycle. So in from X to Y, what is the total distance? 8. Then we will now divide this by number of cycle. Number of cycle, 2.5. And when you divide, anything it gives to you, that is the answer. Huh? We're going to see example later. Number gene kaino keta 5. Akwia? Oh yeah, number 5. Sharp, sharp. Number 5. Number 5. Number 5. Phase. P-H-A-S-E. Phase. P-H-A-S-E. Phase. Have you written that? Oh yeah, let's write. Points on a waveform. Points on a waveform. Points on a waveform. Points on a waveform are said to be in phase. 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 If they are at the same perpendicular distance, if they are at the same perpendicular distance from the equilibrium position, if they are at the same perpendicular distance from the equilibrium position, if they are at the same perpendicular distance from the equilibrium position, are we there? And are on the same points, on the waveform, and are on the same points on the waveform, and are on the same points on the waveform, and are on the same points on the waveform. Have you written that? Full stop. Full stop. In simple terms, comma. In simple terms, comma. In simple terms, comma. In simple terms, comma. Points in phase. Points in phase. Points in phase. Points in phase are one cycle apart. Points in phase are one cycle apart. Points in phase are one cycle apart. Points in phase are 1 cycle apart. Are we there? Full stop. Please, do we have any prep 50 here? Anybody? Prep? Anybody prep? I hope you have past questions. I don't have a past question. Raise up my hand. I want to buy for you. Raise up your hand now. You don't have. Okay, you don't have. You don't have. You don't have. You don't have. Don't worry, God will provide in Jesus' name. Okay? Because you must have past question. No? There is no way you will go and write an exam and you will not know how the exams are set. Imagine you now as a lady. One fine man want to come and marry you. If they come to your house, will they not give them list? Will they not give them list? Or will they just come to your house, your father will say, carry and go? That list is past question now. That list is like past question. Eh? That list is like past question. Or even if they don't give list, imagine you have elder siblings in your house. You have seen what their own husband brought when they wanted to come and marry them. So when you see your own husband, you will start gisting him on time. Honey, do you know you will bring cow? Do you know you will bring this one and that one? So if the man is aware of that thing, which is the past question, that is it. So you must have a past question to be aware of how the questions are being set. Class, let us talk about phase. What did we define as phase? 1, 2, ready, go ahead. That choir is not organized. Please, if you are not reading, you are under attack. 1, 2, ready, go ahead. Ha ha ha. That choir is not organized. I think the black people are on different phase than us. So I want us to be uniform. I want us to be unified. So we are going to read them together. 1, 2, ready, go. Points on a waveform. Good. Waiting. Oh, you wanted to say the other one? There's no need for that. That one is just for your consumption. Oh yeah, pay attention, class. Before we talk about that definition, before we explain it on the board, I want to explain to you in a layman way what phase means. Class, when we say phase, phase means in step. Phase means in what now? In step. Like a jima. So in physics, when we use step, we use phase, phase means that the two things are in step. For example, when we were all in primary school, during assembly, once they start the song that you use and now enter to your class. If you do good. Oh, you don't know that song? If you do good. Oh. Oh. Now, once they are singing that song, you are expected to be matching. Now. Now, you see that once you are matching to the rhythm of the song. Okay? You are matching to the rhythm of the song. If you do good, kingdom, oh, kingdom, oh. So, and if you observe, the person in front of you is also, when you go left, the person will also go right. So, since all of you are vibing to the song, it means you are all in phase. So, when you go left, the person in front of you also goes left. When you go right, the person in front of you also goes right. So, left, right, left, right, left, right. If you are all doing it at the same time, then you are in phase. Then you are in what now? In phase. But a situation where others are doing something, you are doing something else. Have you ever been in that situation before? Maybe your head was not there when they started the music and you just wanted to join. All of a sudden, you now look at your neighbor's leg and your leg is not matching. You're not turn up. You're not turn. Okay? So, imagine the person in front of you is doing left, right, and you are doing right, left. You are out of phase. You are what now? Out of phase. Meaning you are not in step with what others are doing. Imagine you do that in the military. Okay? Then there is a problem. Everybody's marching left, right, zobu, zobu, hey, yimba, hey, hey. And then you are marching the other way. Your commander should not see you. So if we bring the same thing or the same concepts to waves, look at what we mean by that. So when you say 2 points are in phase, they must satisfy 2 conditions. How many conditions, class? 2 conditions. The first one is that they must be at the same what, class? Perpendicular distance from the equilibrium position. That is the first one. And second one is that they will be at what? At same point on that wave. Or again to now. Let me call here point A. This is point A on this wave. This is point B on this wave. This is point C on this wave. This is point D on this wave. This is point E on this wave. And this is point F on this wave. Class, remember, what you are seeing here is a waveform that is continuous. A waveform that is what now? That we do it like this does not mean that it is stagnant. It is not stagnant. It is just your eye that is making it stagnant. Okay? But it is actually a progressive wave. It is a wave going from one point to another. It is moving. So, if you look at these points, point A and point C, point A and point C are similar. We say that they are in phase. Why can we say that they are in phase? If you look at it now, let's assume that this is where the wave originated. It went up small, and then we have a point A. And then it continues, oh, it comes up again. This point A and this point C are the same thing. They are the same thing. And because both of them are the same, we say that they are in phase. Now, which other point is similar to point C? Point E. Is point F similar? No. Point F is not similar. So, A, C, and what now? E are in what now? Phase. That is what we say. They are in phase. Because all of them are the same points. Now, B, is he in phase with anybody? Who is B in phase with now? D. And what now? F. So, B, D, and F are in phase. That is what we mean by phase, class. It is very simple. So when we say phase, phase simply means that they are at the same points on the wave. They are on the same points. It might look as if they are different, but basically, eba and eba both here. It is just because the wave is moving. That is why it seems that here have shifted to this place. But they are the same thing. Let's give another example. So let's say we have something like this. This. And then in JAM, you have something like, here is X, here is Y, here is Z, here is W, here is MO, here is NE, here is Q, here is arrow, here is S, and here is T. They now said, of course, maybe you have statement I. Statement I says this one. Statement I says another one. Statement I says another one. Statement IV, and so on. They now asked, which of the following pairs of points, it can be point of points, are in phase? So from what we have said now, I want us to write down the list of points that are in phase. Are you ready with me? Good. Oh yeah, let's start. Let's say I start with X. X now. X. Is there any point that is in phase with X? Yes. Can you point out? M and S, Abby? Yes. I heard someone wanted to say Z, 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 meaning Z. Is X and Z in phase? No. They are not in phase. Nego debe X neba. X no nenu, Z no nana. Both of them. In fact, you should not even be considering anything down. Because remember we said that phase means that they are the same points. Huh? So X, M, and S now are in phase. So X, M, and S are in phase. Are in phase. They are in phase. Now, which other ones are in phase? Now, let's do Z. Let's do Z. Z is in phase with who? So we can say Z and Q are in phase. Z and Q are in phase. Okay, you wanted to say Y, right? Okay, Y and Guinea. Y and who? Is it Y and N now? Why did you not say W? No. Remember, Y is here. W is also here. So Y and W are not in phase. Yes, but why? Why? Because if you look at this, both of them are like on that horizontal line. So why is this and this not in phase? Now remember, how was Y formed? How was Y formed? Y was formed when the wave was going where? Down. And then W was formed when the wave was going up. Remember, in phase, phase means that you must be formed the same way. And you must be at the same point. So Y and N, are they in phase? And also in phase with T. Are now? So Y, N, and T are in phase. Another reason why you can say that is that, remember I gave you another definition under that one. I said in simple terms, something like that. In simple terms, that points in phase are one cycle apart, right? Good. So you see that another easy way to know it is that this and this should be one cycle apart. Y and W are not one cycle apart. So Y and N are one cycle apart. Okay, one cycle. Good. So they are in phase. Oh yeah, let's go again. Which other pairs of points are in phase? W and R. So W and R are in phase. Are in phase. Do we understand? Oh yeah, let's write. Number 6, 7. Is it number 6? Number 6. Number 6. Number 6. Amplitude. Amplitude. Number 6. Amplitude. Ready? Amplitude. It is defined as the maximum displacement. It is defined as the maximum displacement. It is defined as the maximum displacement of a wave. It is defined as the maximum displacement of a wave. It is defined as the maximum displacement of a wave from its equilibrium position. It is defined as the maximum displacement of a wave from its equilibrium position. It is defined as the what? Maximum displacement of a wave from its equilibrium position. It is represented by A. Capital letter A. It is represented by A, capital letter A, for amplitude. Okay, so look at what we mean by that. So I have this, I have this. So when we talk about amplitude, this line, first of all, is the equilibrium position, in case you want to know. This line, this horizontal line, is your equilibrium position. So the maximum displacement, which is from here to here, that is the distance from this equilibrium position to the peak of the wave, is what we call amplitude. So this is the peak of the wave. You know what peak means, Abi? The highest point. So from the peak to the equilibrium position, that distance is amplitude. Here also, this is amplitude. Here also, this is amplitude. This is amplitude. This is amplitude. Okay? In last year JAMB, one of the questions or surprising questions that JAMB asked was, they said a wave has an amplitude of 2.5 millimeters. They said a wave has an amplitude of 2.5 millimeters. They now asked, what is the peak to peak distance of the wave? What is the peak to peak distance of the wave? Peak to peak. Even though nobody has taught you that before, you should be able to use your brain and know what they are talking about. Peak to peak. So what does peak? Do you know what peak mean? Highest point to highest point. So highest point to highest point. What does it mean? Class, you watch eba to eba is the amplitude. So here is peak to peak. Here to here is also peak to, is also amplitude, sorry. So when we say peak to peak means from the bottom to the top. So what value is it going to be? Is it 2a now? Is it 2 times amplitude? 2 times amplitude. So if I say peak to peak is 2 times amplitude. Meaning whatever amplitude given to you, you multiply by what now? 2. How did we get it? Nka, A plus A, peak to peak. So from here to here is a peak. Here to here is a peak. So peak to peak. 2 times amplitude. Oh yeah, let's take the last one before we start solving some jam questions. Last one, velocity. 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 Are you ready? Velocity. Oh yeah, let's quickly write. Let's quickly write. It is the displacement per unit time of the wave. It is the displacement per unit time of the wave. It is the displacement per unit time of the wave. It is the displacement per unit time of the wave. It is the displacement per unit time of the wave. Full stop. Full stop. Mathematically, comma, V is equal to F lambda on the board, or V is equal to lambda over big T on the board. Mathematically, comma, V is equal to F lambda on the board, or V is equal to lambda all over big T. I hope you know what all those letters represent. Okay, what does F represent? Frequency. Lambda represents what? Wavelength. What does T represent? Period. And then, of course, V is what now? Velocity. So when we are asked to find the velocity of a wave, always remember these two formulas. Okay? Makandoge. It's very important. Okay, so we are going to answer some jam questions. We're going to answer some jam questions before I leave the class. And I'm also going to give you an assignment. Normally, whenever I give assignment, I always pay attention that you did the assignment. But of course, with time, I've realized that no matter what you try to do for somebody, if you don't decide internally, you cannot do anything about it. Is that true? Good. If you don't decide to do it, even if I break your head, you will still not do it. Okay? But if you want to stay at home this year and next year, don't do it. I know you don't want to stay at home, right? Do you want to stay at home? Good. You know, everybody is hustling to enter maybe UNN, Unizik, Unical, Uni-I, whatever. Okay? But nobody is struggling to stay in uni-home. Okay? You know uni-home does not need JAMB. It is come as you are. We offer courses like cookery, washery, eatery, sweepery, cleanery, Eh? We give you BScs in all those areas. Eh? And then finally, we can now give you husbandry and wifery. Eh? Good. If you want to stay, if you want to come to those schools, tuition is free, in fact. No stress. Yes. Okay? So you have to try as much as possible to enter school. Try as much as possible to enter school. Okay. Our first question is taken from the book of 1981, number 22. You know that if you had past question, all these things will not be a problem, because once I say open your own, you will open your own. But you don't have past question, so you are looking at me. No problem. 1981 JAMB, number 22. Look at it. There's a diagram there. They said displacement in cm. And here is time in seconds. And they say that the number here is 0.01. They say that the number here is 0.1. Number here 0.2, 0.3, 0.4. Okay? What am I writing? Okay, yes, they ended it here. So here is not important. Here is not important. So they ended it here. They ended it here. Okay? But of course, you can stretch it. But we don't need that, actually. We don't need that since the time ended here. They now said, the wave shown above, the wave shown has a frequency of, so what are we looking for in that question, class? We are looking for the frequency of the wave. Is it possible? Is it possible? He said, well, yes. Oh, yeah, if you say yes, oh, yeah, talk to me. Solution. What do I do if I see this in JAM? F is equal to? Okay, I can say F is equal to N over T, right? Small t, not big T, oh. Small t, like this. Oh, yeah, waiting be N here. 2. Is it 2 over big T is 0.4. And that will give me what? That will give me what? 5. 5 hertz. And that is our answer. Do we have another way of getting the same answer? There's another way. If you look at this, class, what is the period of the wave here? Is the period 0.2? And you know that frequency is 1 over big T. 1 over 0.2 will still give us what? 5 hertz. So anyhow you want to get it, the answer will still remain the same. Are you with me? Sir, can you say velocity is the displacement by a wave in 1 second? Well, no, you cannot say that. You cannot say that, okay? Because when we define velocity, we are not just talking about a timestamp of 1 second. We're talking about for a very long period of time, okay? But maybe depending on the context, you can actually say that, depending on the context. Another example, taken from the book of 1986, number 34. 1986, number 34. Which year did I say this one is again? 1981, number 22. Mado, go no past question. Go to past question. At this point, you are supposed to be disturbing your parent to get you past question if you don't have. Okay? Now, some of us don't even know how to collect things from our parents. And that is very, very bad. Eh? You don't have the amumu button. Okay? I remember those days whenever I need something in school, I will not eat. Yes. I will not eat. My other siblings might not eat. My mother will not care about them. Oh. But my own mom, in fact, once I don't eat, she wants to know why I did not eat. So once she wants to know why I did not eat, I will not tell her, Mommy, I want this one. I want the other one. She'll say, okay, or yeah, eat, okay? Be like, okay. But your own, you are feeling too big to your own parents. Your own parents. Eh? Daddy, I want this book. I want that. If they see that you need it, the problem is that they don't even trust you. Yes. They know that if they give you that money, Igeji may something else. That is why they will not give it to you. Okay? So you have to learn of ways to collect money from your parents. You don't have to go and collect money from somebody that is not your parent at this stage. Abi? Your uncle. Your uncle. You know you're not talking about your uncle. We are not talking about your uncle here. Okay? So please, go and get a past question. Okay? If they will not give you that money directly, but they will give you money to make hair, don't make your hair for the next 2 months. Buy past question. Yes, look like Onyara. Look like Onyara and pass the... If that is the sacrifice, will you not do the sacrifice? If that is the sacrifice you have to make to get at, will you not do it sharp sharp? In fact, take away my 1 year hair. If you go near hair, after 1 year, maybe low gishi. But for now, we go to low cut. Money here all back. Yes. When my sister and I were preparing for WAEC, when there was no money, because we were saving for both her WAEC and my WAEC, what happened? For like 6 months or so, she did not make any hair. Every morning, what she would do is she would remake her all back. And she will come out and do CC, you will still like her. Nothing changed. Then after WAEC, because we have finished writing WAEC and everything, she started making hair again. And they were like, did you travel? No. She has been there, it's just that she has not been making hair. So if that is the sacrifice you will make it. I beg, next question is 1986. Number 34. Oh yeah, write the question down. A wave of frequency, 10 hertz. Well, we are not supposed to solve this question, but because we have not talked about stationary wave. But let me just do it now. No problem. Let's just do it. A wave of frequency, 10 hertz. Have you done that? Forms a stationary wave pattern. Forms a stationary wave pattern. Forms a stationary wave pattern in a medium where the velocity in a medium where the velocity is 20 centimeters per second. In a medium where the velocity is 20 cm s power minus 1, like that. 20 centimeters per second. Full stop. The distance between adjacent nodes is, let me write the option so that we'll get the answer and know what we are doing. So A says 1.0 cm, B says 1.5 cm, C says 2.0 cm, D says 5.0 cm. So these are the values given. Let's know the one that the answer would be. Class, what did they tell us? What are we looking for? Distance between adjacent nodes. Now, that thing is a big English, but I will explain it. Class, whenever you see anything similar to that, First of all, get the wavelength. First of all, do what? Get the wavelength. In that question, do we know the velocity? In that question, do we know the frequency? Can we find the wavelength? Do you remember that V is equal to F lambda? Can you make lambda the subject? Lambda is equal to V over F. Oh yeah, can you find velocity about 20 over F 10. And when I divide, what do I get? 2 cm. Aqua 2 cm now. Now, but that is not what we are looking for. Don't be tempted to go and pick option C. Don't be tempted. The question said distance between adjacent nodes. And that is under stationary wave, like I told you. Now, when we say stationary wave, I will still talk more about it. But for now, just know that distance between adjacent nodes, that is node to node. Just calm down. I will explain this later. We just have to continue. Node and node. The distance between a node and a node, which is adjacent, is lambda over 2. The wavelength divided by 2. Another way they can ask that same question is they will say find the distance between adjacent antinodes. So if you don't have a node, you will have antinode. So antinode is AA. Antinode is AA. Antinode to antinode. And it is still lambda over 2. Another question they can ask you there is find the distance between a node and an antinode. Node and antinode. That is any A. Node and antinode. Node and antinode is lambda over 4. So asegi node, lambda over 2. Antinode, lambda over 2. Node, antinode, lambda over 4. So similar, lambda over 2. Similar, lambda over 2. Homogeneous, sorry, not homogeneous, heterogeneous, lambda over 4. So once they are different, lambda over 4. Huh? So in that question, I say distance between adjacent nodes, which is node, or borrow lambda over 2. Can you find what take a lambda? 2. So 2 over 2, again now, 1 cm. And the answer is option what now? A. Do we understand? Good. Okay? When we do stationary waves under sound, we explain this node, antinode, more in details, and you will get it. Okay? I don't want to go too far from there. One more question before I leave your class. One more question before I leave your class. One more question before I leave your class. Are you ready? Okay? When I come to next class, we'll solve more questions. We'll solve more questions, but we have to go because there's no time. Are you ready? Okay, my last question for today. Should I solve a simple or a hard one? Okay. Okay, 1988, number 22. 1988, number 22. 1988, number 22. Number 22. Okay? A weirdly looking diagram. So you have this. This diagram is not very clear, but I think this is it. And then the other one, we have. So there are two waveforms there. The one on top, the bigger one is X, the smaller one is Y. The bigger one is X and the smaller one is Y. Like that. The bigger one is X, smaller one is Y. They said the diagram below this shows two waveforms. The diagram below shows two waveforms, X and Y. They now said if the frequency of X, if the frequency of X is 30 hertz. if the frequency of X is 30 hertz, comma, what is the frequency of Y? What is the frequency of Y? What is the frequency of Y? That is the question. Then let me write down the options so that when we get the answer, we know. Option A, 0.1 hertz. Sorry, not 0.1. This is 12 hertz, please. 12 hertz. Option B, 19 hertz. Option C, 60 hertz. Then option D, 75 hertz. Okay? So this is the kind of question you see in the hall. Imagine this was your number one. You'd be like, huh? Haha. Hey, do they even mean good for you? Okay? You know, if you go for an exam and then the first few questions you see, if they are easy, it helps to boost your confidence, abi? Like, imagine you just enter JAM, you log in, sharp, number 1 to 10, simple questions. You'll be very happy. You'll be very, very happy. As you are going down to 15, it will be getting harder. Your face will be shrinking small. Okay, it's better like that than when you start from number 1 and you go dig beam. Okay, at that point you will probably start crying. God, what is this? God, I thought you said you'd be here for me. Oh, people do things in desperation, a lot of things. Okay, let's look at this. Now that we have this, your uncle is already here, so I will just quickly finish this. You don't want to learn? You want to take a break? Oh yeah, pim, Moses or pim. Oh yeah, look up. Class, what did they say we should find? Frequency of gain now. But did they give us frequency of X? We know the frequency of X. Now, oh yeah, pay attention. Listen up. Class, let's start from the known to the unknown. Start from where? To the unknown. Now, do you observe that both of them stopped at the same point? Both of them stopped at the same point. So let's call that time where both of them stopped T. So if that time is T, let's see what will happen. Do you know that frequency is equal to N over T? Shebi, we have seen this formula before. Now, but which frequency are we talking about? Let's talk about X because we know that one. So Fx is equal to Nx over T. You know what Nx mean, Abi? Number of cycle of who? X. Good. Oh yeah, class. What is Fx giving to us? So 30 is equal to, do you know what Nx is? How many cycle did X complete? 1. Just 1. 1 over T. Can we make T the subject now? Oh yeah, T is equal to 1 over 30 now. Keep it like that. Don't divide. Just leave it like this. So T is equal to this. Now, let's do the same thing for Y. So frequency of Y is Ny over T now. Huh? But we don't know Fy. Akwezioku now. So Fy is equal to Kedifebo Ny. For Y is how many? 1, 2.5. That is 2.5. Akwea now. So 2.5 divided by, that is this over. T, Kedifebo T class. 1 over 30. So 1 over 30. So this is 2.5. Division changes to what? Multiplication. Times 30 over 1. Shebi, when you multiply, you get what now? 75 hertz. And that is option gain now. D. So we'll stop there and we'll continue from next time. But please, I want you to do this assignment for me. Let me just write down the year for you. When you go home, you search and solve. Is that okay? Don't tell me no, because if you don't have past question, it is your problem. So when you go home, you solve 1987 number 27. That is your number 1 question. 1987 number 27. You solve number 2. Number 2 is 1989, number 1989, number 19. Number 3, 1999, number 25. Number 25. Okay? So just manage those ones. I know it's very small. Manage, and I will see you when I see you.